Hello, this is Mr. Perez, 6th grade, Module 5, Lesson 2, the area of right triangles. So yesterday we found the area of parallelograms by relating them to rectangles. We know how to find the area of a rectangle. Area of a rectangle, very, very simple. If you get your rectangle and you can identify its length and you can identify its width, and all you gotta do is multiply and basically how many square units would fit inside of this rectangle. Yesterday we went and we changed length and width. We really want to identify, especially for parallelograms and for triangles, using B and H, base times height. So if I want to find the area of a rectangle, multiply its base by its height, and then your answer will be in square units. Now for triangles, so we have an exploratory challenge. Usually this would be where you guys get a chance to really explore the concept. Unfortunately, it doesn't work with this with the video. So I'm going to go ahead and show you this main idea. So if we know how to find the area of a rectangle, how can we create a triangle, in fact, two triangles out of this rectangle? If I were to cut it somewhere, where can I cut it? One nice straight cut that will form a triangle. Well, if you're thinking to go directly diagonal, and if you make this cut, I know it's a little bit off from my drawing, but if you make that cut, you can clearly see we have a triangle on top, triangle on bottom, and these two triangles, they just so happen to be identical triangles. They're the same triangle. I just cut a rectangle in half. In other words, I divided it into two pieces. So that means that the triangle must be half of whatever the rectangle used to be, right? So this leads me to my formula for the area of a right triangle. Remember, right triangle, because it has that right angle in it, two right triangles, and I want to know the area of one of those. Well, if I were finding the area of a rectangle, and I know this says right triangles, but follow along. If I want to find the area of a rectangle, I would multiply the base times the height. We know this, base times height. But if I want to find the area of a right triangle, well, what did we just do to create those two triangles? We divided it by 2. I divided it into 2 equal pieces. So to find the area of a triangle, I'm going to take the base times the height, and then I'm going to cut it in half. I'm going to divide it by 2. You might also see it written like this, which represents the same thing. Half of whatever your base times your height is. So base times height divided by 2, which is the same thing as 1/2 of base times height. So the area of any triangle is going to be those. So this exploratory challenge, part A, didn't quite do the way it was intended, but hopefully we're able to make sense of how do we find the area of a triangle. Well, first find the area of the full rectangle and then divide it by 2. Cut it in half. Let's see if B is going to be relevant to us. Use the shapes labeled with Y. Okay, we don't have those shapes. We really can't do this problem. So I'm going to go ahead and skip over this one. Jumping down to the exercises, I mean, this is really just an application of what we just learned. I want you guys to go ahead, give this one a shot. I am going to give you time to work this out. Just go ahead and pause the video. If you return, I will go over question number 1, and then there'll be another chance. I'll do a 5-second pause. You will pause the video, and hopefully you can work out as many of these exercise problems as you would like to. So go ahead and work out these problems. Okay, hopefully you paused the video. I'm going to go ahead and review number 1 and then give you another 5-second pause. to work out the rest, just in case you needed to see one example. So this is a right triangle. I know that because it has a little box. And in order to find the area of a right triangle, I need to first imagine that it is a complete rectangle, multiply its base times its height. Really what's happening there is we're imagining that the rest of this is filled in and that we actually have a full rectangle. But then we need to realize, well, we don't have a full rectangle. We need to cut it into two pieces. We need to divide it by 2. So to fill in my relevant information, if I want to find the area of this triangle, I need to identify its base. Its base is 15. I need to identify its height. Its height is 8. Remember, the 17 really doesn't tell me much. The 17 is the length of, actually it has a fancy name. It's called the hypotenuse. The hypotenuse, but we don't really need to know the hypotenuse for this finding the area of triangle. So base times height, and then we're going to divide that by 2. Of course, go in order. My recommendation would be go in order and just multiply the top out. And you get 15 times 8, which is 120. And then do the division by 2. 120 divided by 2 is 60. So the answer is 60 feet squared. Remember, this is area is measured in square feet. 60 feet squared. All right, go ahead and take a moment for yourself. Pause the video if you haven't already done the rest. Pause the video, work out as many of the remaining exercise problems as you can. All right, I'm back. I'm going to work out the rest of these problems. There may be some pauses as I use a calculator to solve some of these because I see some decimal problems and I certainly cannot do these problems in my head. So for question number 2, once again, area equals base times height divided by 2. So the base is 11.4. The height is 17.7, and then I'm going to multiply those and divide by 2. So with my calculator, 11.4 times 17.7 equals 201.78. And then I'm going to divide that by 2 on the calculator, and I get 100.89. So 100.89 square centimeters. Number 3, this one looks a little tricky, but remember, when we have our shapes, they could be in any direction. There's no restriction. So identifying the base and the height of this is going to be super important. But just imagine that we were able to turn this triangle on its side. So let me go ahead and trace it so I can flip it around and I could actually turn it so that it is on its side. And just like any other triangle, any shape really, it's just a random shape floating in space, and it could be flipped around, it could be rotated, and I did that. This is 8 inches, got that from here. This is 6 inches, got that from here. The 10 inches don't matter to me today. I have my base, I have my height, so area is going to equal 8 multiplied by 6 divided by 2. That's 48 divided by 2. The answer, 24 square inches. Question number 4. Fractions. Hey, don't be alarmed by fractions. Remember that if you need to multiply fractions out, you should convert them into improper fractions. They're currently mixed numbers. Improper fractions are what you want. But if we write it out, base times height, I really like writing out problems because it helps me just get a good feel for what I'm about to do. And when I see it like this, I know, hey, I have to multiply these numbers, and I know how to multiply fractions. I just have to convert them first. Don't forget we got to divide by 2. So remember 8 2/3, just to do some side work. 8 2/3, you would multiply, and then you would add. and that becomes your new numerator. So in this problem, 8 times 3 is 24. 24 plus 2 is 26, and then you keep the same denominator. All right, so this problem becomes 26 over 3 multiplied by 5 times 5 is 25 plus 3 is 28. 28 over 5, and then we're still dividing whatever that is by 2. 26 times 28, let me go ahead and do that with a calculator. 26 times 28 is 728. That's multiplying the top by the top and the bottom by the bottom, and then we're still dividing whatever that is by 2. 728 over 15 divided by 2. So if I'm dividing something by 2, it's really, I'm multiplying it by 1/2. So this is going to get a little bit complicated, but I'm just rewriting this. If I'm dividing by 2, remember KFC, keep the first one, flip the second one, it's actually 1/2, and then we're multiplying. And then we end up getting 728 over 30. 728 over 30. I'm going to leave it like that. It could be switched around to be a mixed number. Would be something like 24, remainder something. But I'm just going to go ahead. 728 over 30 square meters, which is about 24. Next problem, once again, we have 1 on its side, and we have decimals. That's not a big deal. Area equals base. The base is 32.7 kilometers. What if I call 21.4 the base? Doesn't matter because we're going to multiply, and the commutative property says that we can flip the order. So 32.7 times 21.4 divided by 2 using a calculator. 32.7 times 21.4 is 699.78. But then I'm going to go ahead and divide that by 2, and I get 349.89 kilometers squared. All right, question number 6. Let's see. Mr. Jones told his students they each need half a piece of paper. Calvin cut his piece of paper horizontally. That is going left to right. And Matthew cut his piece of paper diagonally. Which student has the larger area on his half of paper? Half piece of paper. Explain. We have Calvin's paper. We have Matthew's paper. They start out as the same exact size. So really think about, what does it mean when you cut something in half? If I cut something into 2 equal pieces, doesn't matter where I cut it, does it change the size of each piece that is cut? If I cut it down the middle going horizontally, maybe I make a cut going vertically, and maybe I make this cut instead. Now, what you end up getting is different shapes, but the size of the shapes does not really change. I know that because Calvin's paper is cut in half, this piece right here, I shaded in yellow, has the same exact area as this piece right here on Matthew's paper. They have the same area. They're still half of a piece of paper. They're different shapes, obviously, but they have the same area. That's why we get the formula for triangles. It's by taking an area of, could be a whole piece of paper, which is a rectangle, cut it in half. Base times height divided by 2. Number 7. Ben requested that the rectangular stage be split into 2 equal sections for the upcoming school play. And actually, I could take a look at number 6 and see 2 different ways the stage that is a rectangle can be cut in half. The only instruction he gave was that he needed the area of each section to be half of the original size. If Ben wants the stage to be split into 2 right triangles, so we need to split it into 2 right triangles, did he provide enough information? What do you guys think? I think he gave plenty of information. We want to cut it in half, and it needs to be split into 2 right triangles. I think we could just simply point to Matthew's paper, and that could be a really good plan for how they're going to cut it in half. Could they switch how they're going to cut it in half? Probably they could cut it going this way instead. Sorry for the crooked line, but they would end up with the same result. So I think the instructions are just fine there. Cutting a rectangle in half, one way you do it is to cut it diagonally, and you get a pair of right triangles. Question number 8. The area of a right triangle is 6.22 square inches. All right, I kind of know what this problem's about already. They're going to give me some information, and they're going to ask me to find the missing piece. They just told me the area. And they're telling me the base. The base is 3.11 inches. The base is 3.11. Write an equation that relates the area to the height, h, and the base. Solve the equation to determine the height. All right, well, I already know this formula. Base times height divided by 2. That's how I'm going to find the area of a right triangle. And they do tell me the area is 6.22. So the area, the A, I'm replacing with 6.22. They tell me the base, so I'm going to replace on top 3.11 multiplied by the height divided by 2. So I need to figure out what is the missing value for h that will get me to the height. I need to figure out, I need to solve this equation. And this is a little bit different type of equation. So I want you to think of 3.11 times h. We're just going to think about it kind of as one separate problem. Divided by 2 equals 6.22. I want to get rid of the dividing by 2. Divide by 2, don't want it there. I'm going to do the opposite, which is to multiply by 2. I'm going to multiply both sides by 2. And when I multiply the left side by 2, basically this 2 goes away. And then I multiply by 2 on the other side so that it matches. What I end up getting is 3.11h. I dropped the multiplication sign because a number next to a variable means multiplication. The 2's already gone, and this equals 6.22 times 2, which is 12.44. Well, now I end up with another equation to solve. Well, I know that if I have multiplication, I'm going to have to divide in order to get my solution. And this one I could do fairly easily with mental math, but in case you needed a calculator, h equals 4. So the answer, h equals 4. Since we're talking about inches, the height is 4 inches. Notice I'm not putting 4 inches squared, I'm putting just 4 inches because this is the height. Only the area is in square inches, as you can see represented right there. And then the base is actually just inches. All right, well, that wraps up this lesson. As you can see, the following 2 pages do contain some problem set problems for you to practice. I simply ask that you do questions 1 through, in fact, do all of them. Do all the odd problems. Question number 1, 3, 5. Try those out, and then try out number 7. If you also want to try out the evens, hey, more power to you. Definitely is always going to be helpful to do more practice problems. If you run into any issues or you're confused, especially by any of these last problems, go ahead and ask. I will certainly be willing and happy to help you. Just knowing that you guys are working on the math, even though we're not in the classroom, I think is great. So I really push you guys to keep trying. Every single day there will be a new lesson. And also look forward to the exit ticket video, which I'll be working on and uploading immediately when I'm done with this one. See you guys soon.